Welcome on this video about finite sums and products. Today we are going to see the default value of an empty sum and an empty product. We are going to see which kind of toolbox we have for sums and products. So we have the index transformation, we have what I call the stitching sums and products together, and we have the partial fraction decomposition. In the partial fraction decomposition, sometimes you have to use the Polynom Division, but I find it easier to remember that we have three tools in our toolbox. We have also three kind of sums to remember, which are important sums. If you remember it now, you can just pause the video and empty the gaps. In the third part, we are going to see the binomial coefficients and an easy way to calculate something like the binomial coefficient with 20 and 3. We are going to see the recursive definition of the binomial formula and the explicit one. Then we are going to see how we can use it, and it's going to be like that. First thing to remember, the default values of a sum is 0. The default values in an empty product is 1. Now the most important things today are first index transformation, second stitching sums and products together, and third partial fraction decomposition. Index transformation, you think about it when you see k plus 1 or k minus 1 or 1 minus k in a sum or in a product. So how do you do this index transformation? I always do it like that. I look at what is this when k is 1, so at the start. And I realize that k is at 1 is 1 plus 1, which is 2. Therefore, I start with 2 and I go to 3 plus 1, which is 4. And you can see this sum is the same as this one. It's 2 plus 3 plus 4. And this is how we do an index transformation. What do I mean by stitching sums and products together? We also call it removing sums, which are common. The main point is just that sum from 1 to n is actually the sum from 1 to k and 2k plus 1 to n. This can be really useful. We'll see more in some exercises. Now, the partial fraction decomposition. Try to do it, you remember how to do it. If not, let's see how it goes. So there are 3 steps. The first step is to look up and look down. There is a condition for up and a condition for down. The condition for upside, also called numerator in English, the order of the polynomial should be smaller than the one below. So here we have a 2 and here we have a 1. So up is smaller than down. So yes, this is cool for the up. Down, we want that there is nothing before the biggest k, the one with the biggest order. So here it's this one. This should be 1. We divide by 3, up and down. So we get this whole thing. And now that we have the two conditions, so up and down, okay, we can start partial fraction decomposition. Now we do the bottom factorization, which just means that you look for the roots. Here it's easier because you have a squared minus b squared, the same as a plus b multiplied by a minus b, so it's here. But if you have it, you just find it with the methods for roots. And after that, you write what you want. And by that I mean, what you want with the partial fraction decomposition is to have something in the form of a over the part with the root plus b over the x minus the root. So here it's k plus 1. So k minus the root is minus 1. So we do the old version factorized the same as the new version. And then you see we have something like that. So now how do we find a? We first multiply that by what is below a. And when you do so, it looks like that. And then you can just replace k by the root, which is like 1. So if you replace k by 1, then this goes away. And here, since it was in here before, and then we multiply, this goes away, which means that it's not gonna cancel when we put k the same as 1. Therefore, there will be something, and this is gonna be a. Like we replace k by 1, and we have 3 divided by 2. We do the same with b, which means like we multiply by k plus 1. So what I do in the exam to going faster, I just hide with my finger this, and I just replace k by minus 1. I just see I have minus 1 divided by 2. And this is the polynomial we find at the end. Now about Polynom Division, try to do this on your own. This is how I write it down. I'm just writing down cube x squared x to the power of 0, and here I do the same, but it's a personal preference. So then I just do a normal division, but just thinking that this is a square. Let's start like 35. I see 3 here, so I get a 3 because here there's a 1, and then I do minus, then I obtain that, then I just push it down. Now I see that there is a minus 1 here, so to get the minus 1 here I just have to multiply by minus 1, and then this minus 1x, and then I get the square, and this is what I obtain at the end. So this is the conclusion. How to check it, because you want to check it, you want to be sure that it's the right answer in the exam. What I usually do is I check for 2 or 3 position of x. For x is the same as 1, I have on the left 1 and right 1. Same with for x equals 1, I have 7 on the left and 7 on the right. So I'm good. I mean, it's not the proof, but it's good to check. Let's practice. You should evaluate the sum. Pause the video. Okay, let's correct it. So this is just a sum, a telescopic sum, which is important to recognize. So first we do sum of a plus b is the sum of a plus the sum of b. And since this is a constant, you can just put it before, so I just put it here. And after that, here I see there is a k plus 1, so I'm just gonna do an exchange. And this is the same idea. At the start, when k is the same as 1, here I have 2, so I start as 2, and I add 1 here, so here you go. And then I look at what is common. So what is common is the k from 2 to 4, and here from 2 to 4. And I just have to put away k is equal to 1 here, and when k is equal to 5 here. And here you go. This is the result for the first sum. Now, part 2, we have some things to remember. You can either find them back, or you can remember them. For the exam, it's better you remember them by heart, but it's better also you have an idea how to prove it in case you're really not sure about what you wrote. So the third sum is equal to this. And how do you find it? Sum of 1 to n from j is 1 plus 2 plus 3, etc. plus n minus 1 plus n. And you write it then in the other direction. So n minus 1, etc. plus 2 plus 1. And you notice here that you have n times something. And what is this something? It's n plus 1. Therefore, you have n times n plus 1. And this is two sums when you add them. So you just divide by 2. And here you go for the sum. And you have this sum n times n plus 1 divided by 2. If you multiply this sum by 2, you can enter the 2 inside. And this removes. And then you have all the even numbers. And this n times n plus 1. So you just need to remember that one to find this one and this one. Also the one for the odd numbers. Because for the odd numbers, you just have to do that sum of a plus b is sum of a plus sum of b. And here you develop and you obtain n squared. In the second group, we have one formula. And you have to learn it by heart because it's really too long to find back in an exam. So to find it, you have to start from this. And then you make an index change. And you get that. And then you can develop it with the binomial coefficients and with everything. But this is long. You can do it if you have some times right now, but if not, just skip it and learn this by heart because it's really long to find back. The last thing we have to learn by heart is the finite geometric sum. If a equals to 1, then we have n terms plus the one term when k is equal to 0. So we have n plus 1 terms. Now if a is not equal to 1, then we have this. How can you find it? You can remember that the arithmetical sum is a to the power of 0, a to the power of 1, etc. plus a to the power of n. Now think about multiplying this by 1 minus a, then you get the same sum here, minus a minus a square, etc. You can just do it by yourself, it's becomes evident when you do it. And then this cancel, this cancel, this cancel, etc. And only this and this remains, which means that you have this, and then you divide by that, and you have your sum. Here again, it's better to just remember it. So we have three things to remember: this one, and this one. Let's practice. Here I give you the geometric sequence AI, and it's defined by A1 is equal to 8, and AI is AI minus 1 times 3/4. And I want you to find the sum of the first 25 terms in the sequence. Careful, here you will need a calculator, but just at the end. Pause the video. Let's correct it. When you think about the problem, you will end up with this formula. If you're not sure about this formula, you can actually prove it by induction. More on methods of proof tomorrow. Now that we have that, we just want to sum it for the first 25 terms. We know that the constant can be put out of the sum. So here we go here like that. And that we know is a geometrical sum. So it's 1 minus this. Careful, this should be plus 1. So it's 20 to the power of 26. Divided by 1 minus this. Careful, do not forget the 8 before. And this we can do because 3/4 is different to 1. Use the calculator and we obtain this value. First part, the binomial coefficient. So we have to remember this formula by heart. What I want to show you is an easy way to calculate something like that easily. And for that we notice that it's actually the same as this, which is like 20 minus 3. We can just write it like that, because 20 factorials divided by 3 factorials and 17 factorials is the same as this, and the 17 cancel out, so we are left with only that. And when you multiply, you get this number, 1140. Now, binomial formulas, there's a recursive way, easy, and an explicit way. You have to remember it. But when are we going to use it? Actually, we are going to use it here. For that, I have a trick. You remember 1, 3, 3, 1 for to the power of 3. And for the power of 4, you remember 1, 4, 6, 4, 1. How do we use it? Live demonstration. A plus b to the power of 3. 1, 3, 3, 1. 3, a 2, a to the power of 1. And the other way around. B to the power of 1, b to the power of 2, b to the power of 3, a plus b to the power of 3. Same idea with power of 4. 1, 4, 6, 4, 1. Don't forget the powers. So you notice when we have the power of 3, we have 3 of each. So we have 1, 2, 3 for the a, and when you have to the power of 4, we have 4 times b. So 1, 2, 3, 4. Now let's practice. I want you to calculate this and delete this. Now let's pause the video. Okay, and the answer is, so 12 over 2 is the same as 12, 10, and then it's like 12, 11, because you take only 2 of them on the up part, 2 because here, 2, and you're left with 66 if I didn't make a mistake. And for a minus b to the power of 3, it's the same idea as before, except that you should not forget to put inside the parentheses the minus, here also. But of course, when it's squared, the minus gets away, and then you are left with this, formula. That's all for this video. I hope it was helpful. Now you are ready to practice many more exercises on the subject. See you tomorrow at 7 a.m. for the next video about methods of proof.